I picked this problem because A, it's different, and B, it illustrates a concept of something you should understand, which is pressure. How pressure works, and we'll learn about this later, is that the unit weight of a material times its depth will give you the horizontal pressure. So at the surface of something, there's no depth, so it's zero. And at the very bottom, for example, 4 meters of water times whatever the unit weight of newtons per cubic meter of water is, it'll end up to 118 kilonewtons per meter pressure this way. Similar thing with soil. Soil, it's actually a little more complicated. If you're civil, you'll take geotech classes, but if the soil doesn't have internal friction, if it's not sticky, you can treat it like a fluid, and then you just get the depth times the unit weight, and you can get these pressures. And so you can see here, you've got some kind of force from the water that's, I'm trying to eyeball in the centroid of that blue triangle, and then you got some kind of force here, the centroid of that brown triangle. And those are not going to add up to zero. It's going to want to flip over, and to make everything in equilibrium, they tie back this wall this way. It's an interesting problem. Whenever you dig dirt out, you have to have, it's called a retaining wall. It retains the soil back. And in this case, it's complicated because on the inside of the retaining wall, you put water. Now, if this was a real problem in real life, it's even more complicated by the fact that the water can seep into the soil, and how much water you have in soil affects its strength. But we'll ignore all those things. We'll just pretend like we have this problem right here. Okay, after all that explanation, that's why I picked it, because it looked like a real problem. I just drew the free body diagram. So what I did was I actually drew it here. Let me redraw it. I did this right around there. Okay. The first time I did it, I actually didn't read it carefully. This bulkhead, the brown thing, it has a mass of 800 kilograms, so it actually has a weight. I forgot to put that in when I first did the problem. Then everything we cut through this water. So I drew that triangle in there, and I cut through the soil. I also cut through that tie there. This is the free body diagram. And then we cut through some kind of support at A. Typically there should be a moment there, but it says here, which is not realistic, but otherwise we couldn't solve the problem. Assume AD is pinned, and that means just RAX, RAY, no moment. And you do have that unknown F pulled back. So in real life, there would be 4 unknowns, F, MA, RAX, RAY. But to make this solvable, because this is determinate statics, we can only have 3 unknowns, and that's why they did that. There you go, 3 unknowns, as always, and you can solve this. The next step was to get the resultant of these triangular loads. So you need to remember the area of a triangle, 1/2 base times height. So 236 is 1/2 4 meters, that blue triangle, times a height of 118. This 1007.5 was 1/2 the base. First, I looked at that. I thought it was 6 meters tall, because that would be nice, because the centroid will be at 1/3. But no, the soil is 6.5 meters tall. Very unfortunate. Times 310 kilonewtons per meter, and that came out to 1,007.5. The other thing about triangular loads is the centroid of a triangle is not at the middle. It's at 1/3 from the high end of the triangle, or 2/3 from the pointy end. And so 1/3 of 4 is 1.33, and 1/3 of 6.5 is 2.17 meters. That's the resultant of the blue triangle and the brown triangle, respectively. Well, now that we have this FBD, we have the three unknowns, and we can solve. Taking moments about A, again, because there's two reactions, will give us F, and I just made sure I got in all the right distances and directions. F times 6, going clockwise around A. That 236 times the 1.33, which I went through that, it's 1/3 of 4. That's going clockwise around A, so that's negative. And finally, that 1007.5 times 2.17 going counterclockwise around A. Solve for F, 311 kilonewtons. Once I know that, I just sum forces in the X. Let's see, 236 from the blue triangle going right, 1008 from the brown triangle going left. F is going to the right, 311. That gives RAX of 460 kilonewtons to the right. And I didn't write out the Y equation. Can you see it's obvious that the wall weighs 7.85 kilonewtons going down, so the reaction coming up at the bottom is 7.85 kilonewtons.